And all these movements, as I said, are very transparent as long as the applications connect to the cluster endpoints. Some of our customers have logic written in their application itself to handle the failures. In those cases, they would like to connect directly to the instances. And for such purposes, we also expose the instance level endpoints. So in total, we have 5 different endpoints, the 2 cluster level endpoints and the 3 instance level endpoints. So this is how it appears on the RDS console. As you can see, there are 4 records. The top level record is the master record and shows as a multi-ACDB cluster. And you have the 3 child records with the writer and the 2 reader instances. And here you can see the workloads. I have not put any workloads here, but this will show the load balance between the 2 reader instances. Now, I'll turn it over to Vijay for taking you through a demo of this deployment option.
Yeah, maybe this is the best point to see if you have any questions. Yeah, looks like we are pretty good. So for this session, right, I recorded the video. So I'm going to talk over the video. So what we're going to cover is I'm going to create an multi-AZ DB cluster in Postgres and show you what the new option would look like. And then for the next 2 parts, like failover process and as well as read distribution between the 2 reader instances, will be done in MySQL multi-AZDB cluster. So with that, let me get started. So here is the video. Let me play and see how it works out. Can you guys still see? Yeah, it's playing. So that's what I'm going to cover in this demo. So as you see, if you're an RDS console, you just need to simply click on Create Database. You can use console, API calls, everything. So and then we have 2 options, Postgres and MySQL, right? So I'm going to create a Postgres instance, and as Prasad already discussed, right? Postgres 13.4 is the engine version is supported, so choose that. And then here is the new option, which is multi-AZ DB cluster. So that is the new option that we introduced in this. So you choose that, and here is the cluster identifier that we're going to provide, as you've seen in the previous screen, which is a demo DB. So that's what a same instance that I used. And rest of the configurations that you see here are same as our RDS instances, right, that we normally create, like usernames and passwords. And then next interesting thing, what you're going to see here is the instance class. So we use Graviton type instances for multi-AZDB clusters. So you have M6GD instance classes and then memory optimized instances, which are R6GD instance classes. This is the only instance classes available for this instance. So that is another advantage of the multi-AZDB clusters. With that, from the storage point of view, we have only provisioned IOPS as of today, which can change. But rest of the configurations that you see, you choose the VPC and then your subnet that you want to launch your RDS instance. And rest of all the configurations are pretty much similar to the way we create RDS instance. And then from the authentication point of view, we don't have IAM authentication as of today, but that's why we're going to choose the password authentication in this case. The port is configuration is 5432 for PostgreSQL, and password authentication I'm using. From the additional configuration point of view, we have only a DB cluster parameter group available. So if you want to configure anything, you can configure that. And then from the backups, you have the standard backups like up to 35 days. Once you choose all of that, you just simply create the database. So it looks like there is a question in the room. So let me pause the video here. Yes, Krishna? Yeah, question here is there are few options for the authentication is grayed out, which is IAM authentication and then Kerberos authentication, right? So they're not there at this version of the multi-AZDB clusters. Probably that we may need to see if that is on the future. we may be implementing those. So here, now let's get back to the demo part. So here, I think it's playing. Yeah, it is creating the DemoDB cluster. As we see, when we're creating, it is taking the backup as part of the cluster creation. As you see, our DemoDB clusters are created, and then multi-AZDB cluster, and then with one writer, and then 2 reader instances. And if you observe that, right, so all of them are in different availability zones. So if you look at the reason writer instance, right, which is in availability zone 1B, and then the reader instances 2 and 3 are launched automatically in a different availability zone. So that is one thing you may want to see. So whenever you're creating, make sure you have a subnet, have 3 availability zones already pre-configured in your subnet groups. And if you zoom into it, then you would see the endpoints that Prasad was talking about, right, from the configuration point of view. You have a writer endpoint, cluster writer endpoint, cluster reader endpoint. The writer endpoint always follows the writer instance that you see there. And then the reader instance that you use in your application that distributes the load between both the reader instances. So that's how we create the instances. Now I'm going to take a pause here to talk about the next 2 parts of the demo, which is failover process. We talked about, right? Normally, failover takes around 35 seconds typically. And then for reader capacity, the reader endpoint that we've seen, so how it is going to distribute the load between both the instances. With that, for this part of the demo, I already created a MySQL multi-AZDB cluster. So I'm going to use that multi-AZDB cluster. Before we get started, I'm going to show how the instance looks like from the MySQL side point of view. Yes, here, this is the instance I'm using from the MySQL point of view, which is on 8028.
Question.
Yes, there is a question, so I'm going to pause the video here. Yes.
Question on the reader instance, right?
Yes.
You have a reader endpoint, which is round robin between the 2 reader instances.
Right.
And as per the logic, it is because it's semi-synchronous, you want to make sure at least one acknowledgement comes from one reader instance. Say, for example, I need a strong consistency in reading. Will I be able to use, what is there any endpoint where I can use a strong consistency in reading? Because sometimes, right, if I use the reader endpoint, it may switch back and forth between the 2 reader instances, and one of them may be lagging because of whatever the reason is.
That's right.
Is there any option available where I can do a strong consistency?
Yes. So question here is there any specific reader that we can use to maintain the strong read consistency view? As of today, we don't have anything, any configuration that you can use to go to the specific reader, but that is a good feedback. Probably we're going to think about it. So with that, I'm going to. So yeah, so if you want a consistent view, right, you need to go to the cluster endpoint, right, which is the writer instance. So that is the one option.
It is a balance between performance and how do you want to read. So if you are not overloading the writer, you can read from the writer itself, so your reads are consistent. So the minute you start waiting for both the standby instances to be consistent with the primary, then you're introducing a lot of lag.
Yeah, at my company we had certain queries where we needed strong consistency, and other queries where we can have somebody for the strong queries just was
Yeah. Yeah, with that, I'm going to continue. This is the MySQL cluster I'm talking about. This is what I'm going to use for the rest of the parts. Here, what I have, I'm going to pause here before I talk about it. On the left side, on the top left, I have an application, EC2 instance. I'm running my application, which is a Docker application with few microservices in it. And then I'm using Docker Compose to run those applications, right? So let me see, that is the one. On the right side, I'm going to use for the scripts that I'm using to show the demo. So that is the 2 sides, that's what we're going to see. So as you see here, I have few Docker microservices. I'm going to bring them up using Docker Compose to Docker Compose, which manages these microservices, right? So I'm going to make sure that is going to be up and running. So I'm going to start the Docker Compose. And here are the, so before we start the Docker Compose, right, I just want to show you how the configuration looks like, right? If you see in for my each and individual microservices, there are endpoints. So if you see here, there is a cluster writer endpoint and then reader endpoint used before these for all the microservices. So that's how you're going to configure whenever you launch a multi-AZDB clusters for your microservices applications. You're going to use those endpoints within your configuration file. So with that, I'm going to, those are some of the products and then microservices that we have, and all of them configured with the endpoints that we just created. With that, that's how the configuration looks like, and then you use usernames and passwords to connect to your application. And then I'm going to bring up the Docker to bring all the services up, all the microservices up. So Docker Compose up, all of my microservices are up and running right now. Now I'm going to show how the application looks like. This is a cute, an Octank fashion application, retail application that I've created, so that we're going to see on a Cognito window. I'm going to open that application, how it looks like. So those microservices are behind the scenes. We are using those microservices, right? So this is a small application just for our demo. That's what I'm using. So with that, let's go back to the failover process that we're going to see, right? On the right side, I have scripts that I have created, which is a create order Python script that basically generates quite a lot of data into my multi-AZ cluster. And then we're going to do a failover after that while we are generating. So that script will automatically try to reconnect to the multi-AZ cluster and then see how the failover process would look like. So while my orders are getting created, let's connect to RDS instance and see what's really happening within the database. So here, I'm just connecting to the cluster using the cluster endpoint, and then I'm going to see the table that orders are getting generated. I just want to show that actual orders are really happening within the database. So as you see, number of orders are 515 there, and then I'm going to count again to see. So basically orders are going up. So there is an active database activity happening. And then while activity is happening, what I'm going to do is I'm going to initiate a failover from the console. So going back to the cluster, and then from the actions, I'm going to click on failover process, failover, and then confirm that failover. So this failover basically triggers immediately. So failover is happening. So let's get back to my script and see. Yeah, failover is started here, right? And then failover started around 6:59 seconds, right? 00 seconds. And then let's see how long it's going to take. So orders are failed. My script is trying to reconnect to the cluster, multi-AZDB cluster, and then successfully completed. So I'm going to pause here to show you what's really happening. So here, the failover time is completed within 24 hours. So that is another advantage of the multi-AZDB clusters. Why it took 24 seconds is, if you see, right, from the architecture point of view, the readers are already up and running. Not like in a multi-AZ, you don't have the secondary up and running. In a multi-AZDB clusters, readers are up and running. In case of a failover, what we do is whatever the logs that we have in the local SSD, those will be processed, and then your instance will be up and running. So that's why you will see much better availability with multi-AZDB clusters. So that's the second part of the demo. So now I'm going to talk about the third part of the demo using the reader endpoint. So for that, I have another script which I'm going to start in few seconds. Probably this, yeah, so this is the time I was talking about, 24 seconds, right? So I just gave some time for us to discuss about that. Yeah. So now I'm going to see the third part of the demo, which is the so that's good. So yes, so now we're moving on to the third part. For that, I'm going to use load multi-AZ cluster reader Python, right? So what it does is it's basically distribute using the multi-AZ DB cluster reader endpoint, and then which distributes the load between both the reader instances. So if you see here, the endpoint RO is the endpoint, the reader endpoint that I'm using, and then which is also using some of the threads I'm using, number of seconds that I want to run the script, all the configurations that I'm passing through that. So once I start the script, if you see, right, multi-AZDB cluster 2 and 3 reader instances, the workload will distribute between both of them. This is how you normally expect when you use the reader endpoints within the multi-AZDB clusters. That's how we distribute the load between both the reader instances in a round robin fashion. With that, I'm going to get back to the presentation, which is the next part. Is the demo is over about the 2 reader instances in which regions it is currently available, right? So currently these are the regions multi-AZDB clusters are available. And then the main thing I want to take away from this slide is the RDS MySQL and Postgres versions. If you're using MySQL, make sure you're on 8.0.28, and then from the Postgres side, which is 13.4. And then currently, MariaDB, Oracle SQL Server are not supported, and these are the reasons currently we have this feature available. With that, I touched when I'm creating an multi-AZDB cluster, I touched on this topic, which is Graviton instances. We support only Graviton instances in this multi-AZDB configuration point of view, right? So we have 2 options, right, which is Graviton 2 and 6 GD, which are general purpose instances, and then memory optimized instances, which are R6 GD. So another advantage of these is to give you better price performance, right, for your instances. So you have another advantage of using the Graviton instances. And then these are, as you see here, for general purpose, you have up to 256 GB of RAM and 64 vCPUs. And then from the Graviton, so from here, from the memory optimized instances, we have up to 16 GB RAM and then 512 GB RAM, up to 2 vCPUs to 64 vCPUs currently available for these options. And both of them have local NVMe SSD stores available. So that's where we're going to keep our wall logs or binary log files, right? And then it's good for high performing networking applications. The general purpose is basically suitable for CPU intensive workloads. Memory optimized instances are good for the high concurrent connections and high throughput activities. And then another thing, storage, is right now, as you normally know, right, RDS instance provides GP2 and provisioned IOPS, right? But with this option, we are using only provisioned IOPS. And then additional storage options might be available in future, probably enhanced storage options might be available. But right now what we have is provisioned IOPS. Provisioned IOPS are suitable for production workloads with intensive concurrent connections or throughputs that you're looking for, and then latencies that are looking for. Provisioned IOPS are the best choice for the production workloads. Right now you can have up to 64 terabytes, and it normally delivers single-digit millisecond latencies, provisioned IOPS. And then you can have up to 80,000 IOPS for your workloads. So that is, those are some of the characteristics of the provisioned IOPS. And with that, we're going to talk about the next one is getting started with 2 readable standbys. So here I want to show, right, if you're using AWS CLIs, right, what is the difference between multi-AZ clusters and versus multi-AZ DB clusters with 2 readable standbys. If you see the CLI, right, here we are using create DB instance. So that is a standard DB instance that we create, and then configurations or rest of the configurations are same. But the another thing with multi-AZ DB clusters with 2 readable standbys, thus the API call is totally different. It is create DB cluster. That's what we need to use. This will create cluster with all the instances within that multi-AZ DB cluster that you see. So, and then you have option to choose the engine version, and then MySQL or Postgres, and then engine versions. So this is the difference, one of the difference between creating an RDS instance versus multi-AZ DB clusters. And if you want to migrate your existing workloads that you are using, if you're on a single AZ or currently if you're on a multi-AZ, what are the options available? First option is snapshot restore. So for that, you can create a snapshot using create DB snapshot. And then other one is when you create a DB snapshot, you use restore DB cluster from snapshot. This is the new API call that we introduced that will take the snapshots that we took, and then that will create the multi-AZ DB clusters. These are some of the differences, right? So, and another way of migrating your existing workloads, you are using the AWS database migration service. So as you see here, your applications are pointed to the multi-AZ DB instance, right? Multi-AZ clusters, and then you can set up a replication using AWS database migration service, DMS service that we have, and then you can replicate ongoing changes to the multi-AZ DB clusters with 2 readable standbys. So this is another option available, and this is the blog. It's well written, and then it has all the steps that you need to follow to implement this, which is the minimal downtime migration option that is available right now. And then I want to quickly touch base on what we talked, and then what are some of the differences that we see with respect to single AZ, multi-AZ with 1 standby, and multi-AZ with 2 readable standbys. So from the additional read capacity, if you're on a single AZ, all you have is that single AZ instance that you need to use, or either you need to add an additional read replicas, right? But with multi-AZ with 1 standby, you're limited to the 1 instance as well. For reads, you may need to spin up the additional reader instances. With multi-AZ with 2 readable standbys, which brings 1 instance, 1 primary, and then 2 readable standbys, and those standbys will act as a failover targets for your high availability configuration as well. So that is one thing here. And then lower latency, as we discussed today, right? Multi-AZ DB clusters provides us 2 times faster transaction commit latency, and also any issues with EBS jitter, we'll try to reduce it because that doesn't come as part of the commit transaction path. And automatic failovers, as we've seen in today's demo, normally with single AZ, there is no high available option. So if your whole AZ goes down, then you need to wait for it to come up. With multi-AZ with 1 standby, you have a standby which acts as a failover target in different availability zone, but you don't have access to it. But the failover time normally takes 60 to 120 seconds, so mostly 2 minutes. With multi-AZ DB clusters with 2 readable standbys, right? As we've seen in the demo, typically it is less than 35 seconds. And higher resiliency AZ outage point of view, if whole AZ goes down, right? As if you have backups enabled on your single AZ instance, we continuously take those backups to provide you point-in-time restores. We take every 5 minutes binary logs or wall logs to S3, right? That is up to RPO is up to 5 minutes. But whole AZ goes down, then we need to wait for it. Your RPO, RTO may depends on availability of those AZs. And then from lower jitter transaction commits point of view, as we discussed, for single AZ, no optimization for jitters. If EBS volumes, if you find some jitters, your application will see those jitters. With multi-AZ option as well, even your standby EBS volumes have any jitter happens, then your application may see those jitters. With the multi-AZ DB cluster options, as we do not 100% depend on the EBS volumes within the sense that in your commit late paths, right? So that's why you would see better performance with multi-AZDB clusters. With that, I will pass it on to Prasad to conclude our session today.
Thanks, Vijay. So in summary, the takeaway from this presentation, this multi-AZDB cluster is offered on 2 engines, Postgres, MySQL. Postgres, it is on 13.4 version. MySQL, it's on 8.0.2.8 version. And it offers 4 distinct benefits. The first one is faster transactional performance or reduced commit latency by about 2x times. Second one is failover times are much faster, typically under 35 seconds. Third one is the read scalability with 2 read replicas. Fourth one is further maximize performance by separate endpoints for write and read workloads. So have provided additional links here if you want to know more and get into the details of this new deployment option. So that concludes basically the presentation part. So open it up for questions.
Yeah, we have 4 minutes. If there are any questions, happy to take.
One question on stream. Where can we download the slides?
It's, I think.
Probably from the registration, if they're registered, right? We will send, the Percona team will send those slides and make it available within their website, I guess.
Another question
Yes.
here?
I have one question that you mentioned about that from the primary to standby. If one standby acknowledge and the primary commit, and in that case, if that primary commit, another standby may not got that message. How that could resync those standby cases?
Can you repeat the question? Sorry.
There is a possibility you mentioned that primary send that commit message to both standby. If one standby acknowledge and the primary will commit, what if that another message to another standby got lost and primary crash? And how do you get two standby synchronized in this case?
Yeah, so the question is when the primary sends the commit message to the 2 standbys and one of the standbys crashes.
Not standby.
Yeah,
It's
primary.
One standby acknowledge and the primary commit.
Yes.
And then primary get crashed. And then in this case, that is possibility that two standby not really in sync.
Yeah, so when the primary crashes, one of the standby instances will be promoted as a new primary, the one that has committed, and the replica lag mechanism will kick in, make sure the 2, the primary and the secondary are in sync, while another instance gets created and is brought up back.
Good question. Any other questions?
Do you have any cost documents? How much of the cost is?
The prices are published on the RDS pricing page for PostgreSQL and MySQL.
How many readers can we add after that?
No, currently the cluster is configured for a maximum of 3. So there's no flexibility today to either remove the instances or add more instances to it. It comes with a predetermined 3 instance configuration.
Are there any similarities between this and Aurora DB clusters?
What is the question, sorry?
Are there any similarities between this and Aurora clusters?
So question here is, are there any similarities between Aurora and the RDS multi-AZDB cluster? No, not at all, because the way we write here is totally different from where we write in Aurora, right? Except the endpoints, cluster endpoint and then reader endpoint, the way the behavior looks like, that is the only similarity that you see. But rest of the technology, rest of the Aurora technology, storage technology is totally different from what we use here. Here we use local SSDs.
There's some differences in the sense Aurora can support multi-write and it supports more instances in the clusters.
What about in terms of replication, like failover times? Are you similar?
So question is, what is the difference, what is the failover times would look like between both of them? Yeah, Aurora is typically like 100 milliseconds, right? Or 20 milliseconds that I have seen, minimum. But there is totally different here, right? Because Aurora uses the same storage for both writers and readers. So in case of a failover, everything data is there. It's nothing. It doesn't need to apply any local SSD storage volume logs. Doesn't exist. That concept doesn't exist. So data is already there in Aurora. So that way, it's totally different. In case of a failover, we don't need to spend much time. Looks like our time is up. You have any other questions? I'm happy to take offline.
Sure. Any questions from the audience in the stream?
Cool. Thank you. Thank you for your time.
Yeah. Thank you all.